Thank you, Stefan. We'll try to get through this quickly. You must be hungry. Let's see, does this work? No, that doesn't work. Alrighty, so we work on, at DLR, we work on robotics for space and for ground, and you will see in this presentation where that synergy comes from. And to move more towards space, the first thing we want to especially tell you about is, as Stefan was just showing with Matthias getting stuck, if we want to help him, we need to provide robotics that's able to actually do some of the jobs for him together with him. And the most important things are two. One is the need to be able to be dexterous enough. So you can see here's a robotic arm that's the space hand developed at DLR. That you can see has some level of dexterity that allows you to teleoperate it from inside the station to perform some dexterous tasks. The other thing is that it needs to be safe. So this is an MSR arm that we developed also at DLR. Now, my colleague here is pushing him around not because he needs help. It's more to tell you that if it gets in your way, you should push it or get out of your way. Similarly, for on orbit, we also have the same idea involved here. This is called compliance control and impedance control, where you can see that 60-kilo arm can be just pushed around with just a couple of fingers. And that's the safety and dexterity that we want to have in a space environment to keep things safe and capable. All right, now we go into telerobotics. Now, we have been developing this idea of teleoperating robotic assets on a planetary surface for many years already, and in the last couple of years we moved more towards looking at cislunar space. So the idea is that we would have astronauts and robots on the ground that could be teleoperated from the, not the person, sorry, just the robots. Could be teleoperated from ground or from station with different kinds of intuitive user interfaces. Here's an example of such. This is already on board the ISS already. So you'll see, I realize it's a bit of a mess there. In fact, that's a picture I never show my kids because they will never clean up their rooms. Anyway, back to what we're talking about. So, an important thing is to have a good user interface, a graphical user interface that makes it easy for you to use a complex system. We also like to give you the possibility to command using a joystick for direct teleoperation. And we would like to give you the possibility of interacting with your environment, and this is a force reflection input device with 7 degrees of freedom, so you can really move freely around and also grasp stuff. Now, we got a bit ambitious, and we started looking into not just using one robot, but a team of robots. And not only that, we want to have different types of robots with different kinds of tasks. So on the upper left corner, you see a small crawler about the size of about 30 centimeters across that allows you to go do recon in tight crevices over tougher terrains. On the lower left, you have a humanoid robot. Now, the purpose of it being humanoid is twofold. One is that it has bimanual capability, so that you can really grasp onto stuff and do complex tasks. And the other is it's easier to anthropomorphize yourself into the robot to teleoperate it. You know, you're more familiar with having 2 arms yourself. On the upper right, we have a lander equipped with an arm that allows you to do component handovers and sample stowage. And finally, we have you know, what you're more familiar with the rover. In fact, Ian, you showed that in a slightly different dress. That's an Interact rover that lets us traverse a larger territory. Now, since 2015, we started doing just about every year some ISS to ground experiments to show that we can, in fact, teleoperate a robot on a surface. We use Earth as our simulated heavenly body. It is a heavenly body. In this case, we're showcasing together with our Roscosmos partner back then, the ability to do telepresence with force reflection. So the astronaut is using a force reflection joystick to command the robot to do the handshake with his wife. Now the point here is not just to show that you can handshake. The point here is to show that you can handle a stochastic environment. So you don't know what you're touching, but the robot can safely handle the surrounding around it, and you can feel the surrounding, which for geologists especially is terribly important because they can then touch and feel around their surroundings and know, oh, this is what it feels like. Now, we also want to look at the robot as an intelligent coworker, so we started looking into supervised autonomy and Metron Surface Justin. And in here, we use a graphical user interface to command the robot at a task level. So the good thing with this is that you don't have that kind of mental load. So we've spoken to some of our ISS crew before, and they said, I can teleoperate with telepresence, it's great, but after 20 minutes, I get a little tired. I don't know that as a physical load, I think it's more the mental fatigue. So all of these tasks that you see the robot doing, those are done with task level commands. The robot gets a task level command, and it then uses local intelligence to execute these commands, do the planning, do the trajectories, and handle it all itself. Right. So we started moving towards and looking at using supervised autonomy to command the robot like an intelligent coworker, and looking at a commanding robot as an extension of yourself in telepresence, because well, our astronaut feedback was when they have telepresence, they want to be able to not have to take care of the robot all the time. And the other way, when they're commanding the robot like a coworker, they go, well, sometimes I want to just command it myself. So this is our first foray into this. This is a ESA DLR experiment, again, in analog 1, where well, Luca Palmitano used the force reflection input device to command a robot to pick up samples. Now, the sample collection is done in telepresence mode, and then the stowage isn't done in supervised autonomy because you know where the stowage place is and the robot can handle it. Now, moving right along, we started looking forward towards looking into commanding a team of robots. In 2020, starting last year, we started doing validation experiments on orbit, and here again, you can see the robot being commanded by Samantha to do another handshake. That has kind of become an in-house score, who can shake hands with more people in different conditions. And this being Turin, we just had to show Samantha doing her work. Now, we were talking about being able to command the robot with mixed modalities. Here is a case, a very, very simple task. But for example, right now, you see the robot getting himself situated to grab onto a lever. That is done in supervised autonomy. You just tell the robot, go and grab onto the lever. But the lifting is done with this force reflection device. That's where you want to be able to feel whether a lever is stuck, whether a lever is free. So, you know, a lot of stuff gets put into this user input console in a very intuitive way so that you don't have to think about it. The analogy we like to put on is if you go to a coffee machine, you press a button, and you get your coffee. You don't think about it, but then you go, I want sugar, I want to stir it, whatever. That you do in telepresence, and that's what we want the astronaut to be able to use our device in such a way that you don't really need to think about it. Now, a lot of this technology we also develop on ground, and this is a reciprocating life cycle, where the technology gets brought back also on the ground, and then when they get developed further, they go back. Here's the case where we have a user using a hand exoskeleton to work in a virtual world where he has force reflection down to the whole hand to be able to teleoperate objects in virtual. We also looked into bringing this technology into home assistance to be able to help senior citizens at home and people with physical disabilities, where we would have a robot that can be commanded from a station where my colleague here, surrounded by this robot, is commanding the robot at a patient's home, where he can help the patient with his daily needs. Now, on simpler tasks, the patient could just use a tablet to command the robot, but more complex stuff, or in this case, requiring medical knowledge, you would have somebody in the expert center commanding the robot. Let's see. Right, so this is, I didn't realize how long it takes for the robot to walk over there, but okay. So this is where the robot is supposed to administer an injection. We'll skip through past the needle point. Alrighty. Now, another bit that is very useful for us is telesurgery. This, in fact, was one of the topics that our colleagues across the space community is interested in doing also on station. You see the similar force reflection input device being used for this context. Again, you see that life cycle, that reciprocation of space to ground and ground to space technology transfer. This also helps us be able to bring medical assistance to places that are hard to reach on Earth. One of the things we're very excited about is a project we're working on together with the World Food Program for delivering medical supplies and food and sustenance to difficult to reach places. And here again, we're using using teleoperation, where we're using differential steering to command this big thing to go across anywhere you need to in different tough terrains. So you can see here, this is the differential steering that we have together with all the mapping technologies that go along with it to make it possible. Last thing, this will take 30 seconds. Because we want to bring it back to space. So what's next for us is we're looking towards being able to work on space assistance technology. So the idea there is through past work on the Simon, which is a robotic assistant that can float in the ISS, to Robonaut from NASA. What we're looking for is a station butler type of device, which allows you to have an assistant in a gateway situation or on the ISS, where the robot can be the active companion of your crew to do more mundane tasks and doing assistance activity. It also allows you to have a ground expert to teleoperate it to become your direct contact with the ground experts to help you with working out your tasks. And with that, I can see I'm being stared at. Thank you.